Can you see my screen, correct? Okay. Okay, great. Okay. Okay, first of all, class, thank you for being here. I move to the next slides. If you cannot see that, please let me know. In this live session, I'm going to walk through our studio with three examples from three different packages, from three different data sets, and then I will also look at the individual assignment requirements to see how you prepare your assignments. So, um, till now, in my class, all of the students except one submitted the topic, and I already approved that. Hopefully, all of you started working on the packet on the analysis, because as I said earlier, this is not. I understand this is not an easy task to go with one day works, but in the team project, you work with a team, and this assignment is exactly as an analytical part of the team project. Basically, I also provided you an example. This is a draft. You can see my word, correct? Just one confirmation is okay. Anything? Anyone? Okay. Okay. Thank you. You know, start with an introduction, very short introduction, not more than two or three paragraph. The shorter, the better. Even one good paragraph, it's okay for this assignment. I don't need any literature review for this assignment. I only like you to just focus on the analysis part. Then go with your hypothesis. You already know your data set, you already know your topic. The hypothesis usually is a writing in your topic in a question way. For example, if you are going to compare blood pressure between black and white population, the hypothesis is there, and there is no significant differences between black and white population. Between There is no significant differences between blood pressure in black and white population. This is the hypothesis. Usually, their research question is in form of the question, but the hypothesis is a very neutral sentence, because by default we don't know is there any significant difference or it's not. For that reason, there is a very standard sentence I wrote here: there is no significant differences between x and y. This is the typical format of writing the hypothesis. Then discuss your data sets. Not more than two or one paragraph. For example, in my class there is not more than four different type of the data set. One of them is the medical national data by county. The other is the Minnesota hospital admission, Minnesota admissions, and finally the imaging. I call it, even that's the Minnesota imaging service, but providers. That's a different data set. If you are using any other data set that describe that, as I know only one or two students are working a different data set, this is fine, but just make sure to describe your data set, because the reason for that is if someone else try to duplicate your analysis, what will be the results? Or if you want to report something and your data set is in for 2012 and I'm checking that with data set in 2014 is different, so I can show that okay, it's because of two different data sets. Then go with the material and methods. In this is the most important part of your assignments. Usually, most of you are going to just compare, have a very descriptive, very basic descriptive analysis. In the very basic descriptive analysis, you're gonna have a descriptive table to report your table. you're gonna use one simple t-test, either paired t-test or unpaired t-test. I recommend you to don't go with a paired t-test, go with unpaired t-test, otherwise you need to equalize. You don't need to do that. RStudio automatically do that. You need to equalize your sample, and for that reason you're gonna lose a lot of observation. For that reason, in a real environment, we going with unpaired t-test. Otherwise, in clinical studies, this week discussion was about experimental and non-experimental. In experimental studies, we try to go with a pair because for one observation in a control groups, we expected to see one observation in the real group in the other groups. For that reason, it's gonna be paired t-test. But usually in the social science research, it's going to be unpaired t-test because, for example, we are going to compare Virginia with Maryland. They are two different states, two different population. We try to normalize the data. We try to equalize everything, but we are not going to fix the population in Maryland with population in Virginia. We can try to go with percentage to normalize the data, but we are not trying to stay with the same observations. And the differences between observation and and the sample is, for example, if you have 100 sample and every sample repeated 3 times, your observation is going to be 300. If for that reason, usually observation is more than sample size because there is a chance for repeating uh, the population. So that was just for your information. You don't need to repeat. You say anything about that in the material and methods. Then go with a table like this and describe your variables. For example, in this example, there is a it's a comparison between length of stay between acute and non-acute care hospitals. So there's two variables, length of stay, and the group variables is acute and non-acute care. Or here, I think it's a critical care access. So CAH is for go with critical access hospital. So we have two variables here, average length of stay. This variable is numeric variables. The source of data is Department of Health Minnesota. The year of data is 2012. And this is the categorical variable, the same source of data set. If you are working with two different data sets, so probably you can have, as I know, only one person is working on that. Then go with your method. Your method is a quantitative research method. Just provide one short sentence and add citation for that, not more than 1 or 2 lines. If you like to write more, that's okay, but the requirement is not more than 1 or 2 lines. And just say why this is the quantitative research, and then add one citation, and then go with the method. The method here is a quantitative method, and you are going to use at least a t-test. If you are working with more than two population, you're going with ANOVA test. If you are trying to find a correlation between 2-3 different variables, it's going to be a regression model. As I know, most of class is working with only two variables. I force you to stay with two variables because I don't like to complicate everything. So we are trying to learn a regression model in this class because you need to understand later, but for this I don't expect you to just go with regression analysis. And then go with the data analysis process. Is very similar. The data analysis process is you're gonna say I'm working with RStudio or any other package. For this RStudio, for example, I'm using the t-test. The RStudio use type of wet sample t-test to do that, and look at the wet sample t-test, provide one single line definition for that, and that should be data analysis process. And then go with the result. The result sections has basically the result section has 2 or 3 different parts. depends on the way you are trying to describe your findings. The first part is findings. The findings is in terms of the tables or in terms of the figures. So we have tables, we have a figures, and we have a describing of the findings. So first of all, go with a table. Any table report a mean, a standard deviation, and number of observation. It should be a table like this. And here, the n and observation for this data set was the same. So this is the mean and this is the standard deviation. And then we run a t-test, and this is the result of the t-test. And as you see, the mean in critical hospital were 550, and mean in non-critical hospitals were 7, almost 8,000. And for sure this is a significance here. So these tables presents the mean and the standard deviation. So basically this table shows us that what is let me close this one. Anyhow, I can't do that. Okay, this table shows the mean and the standard deviation to see how, and after this I wanted to see this mean is a real mean. Is it a real means of the data? For that reason we are going to look at the box plots or density plots. I recommend you to go with both of them because the box plots compare the means, but the density plots show you the distribution of data. As you see here in figure 1, there is a long tail in, and if I just run it before considering any acute and non-acute care, there is a tails in the data here. After 6 till 12 there is a tail in data, and probably there is potential outliers in this data set. For that reason we need to go with a sensitivity analysis to see what's happening in the data if I remove the outliers. For the sensitivity analysis, if you like to report all the findings, that's fine, but for me it's not. I just like to see if you remove the outliers, what happened to your findings. Is p-value changed or no? If you remove the outliers, you can just run the t-test with a new data set and then see if after removing outliers, is it still your p-value is significant. If this is the significance, so I can say okay, the outliers did not significantly impact your outcome, so you can stay with your current tables. But if after removing the outliers you see okay, the p-value changed, not significantly changed, for example if is it 0.04 and in the new analysis is less than 0.05 and it's not significant, then you need to report the table of the descriptive table. It was all about the results, and then you just need to shortly report your findings, because this is the table. You're going to say okay, this is mean between these two variables xy, and then you go with the p-value. It's significant because of this, it's not significant because of that, and then you can cite the tables and figures, say okay, this is not, it was outliers in the data set because as was provided in table 1 in figure 1, and so for that reason I try to do sensitivity analysis, and that I tested the result and it's not significantly different, so I stay with the result. And then this is finished, this is the findings. At the very end you just need to report not more than one paragraph, discuss your go with your recommendation, because we already discussed the findings. For the discussion is a non-statistic way to report findings. So for that reason usually we don't report any numbers, we don't report any significantly difference, between the variables, we're gonna say, okay, if there's a critical care and non-critical care hospital, length of stays in critical care hospital is higher because of ABC. That's something like this, and go with at least one policy suggestion if you are working in a real environment. So one policy suggestion. I recommend two or three policy suggestions, but I like to see you take care of the policy suggestion. It doesn't matter you report two or three. I at least to see at least one policy suggestions. For every study, there is a limitation. The sentence for limitation should be something like this sentence, but I like to just describe in one or two or three lines about the number of limitation you have. And here I say I put the conclusion and policy recommendation as a separate. So if you discuss this in policy recommendation, the discussion, you don't need to stay to report again the recommendation, or you can discuss your findings here and just go with one or two lines recommendation as this. The conclusion, the discussion and conclusion is very similar to long abstracts. For long abstract, for example, you have one or two line about your subject. There, each abstract is a structural abstract, has four sections, one or two line introduction to discuss about the type of the research, because someone, I'm going to read only the abstract in the real environment. Then you're going to go with your research method, and then you're going to go with your findings, and then with conclusions. So basically, if you give two lines for each part, you're going to have the conclusion and recommendation, not more than 6 to 8 lines. This is the all of the, and then go with the reference, follow the APA, and this is completely okay if you just want to go, if you want to use this draft as your draft, modify words and keep as it is. This is in the APA format. Just need to report your topic, date, and your name. Please make sure to say add your name, because I have some experience with some students, they didn't add the names. I need to add it myself, look at the class and find who submitted this one. This is all about the individual assignment 2. If you have any question, please let me know, otherwise I'm gonna go and work with RStudio. Go ahead. Okay, are you in my class or you are in Dr. Azar's class? Okay, Dr. Azar, do you have any do you want anything to add here? They are looking to see this draft for your class, and I believe you posted that. Okay, but the instruction will be the same as this instruction. Also, as I know, there is an individual assignment too. I'm not sure if we have instruction, any other instruction for the individual assignment too. Let me see. My Dropbox probably. As I know, I just posted this one. Just give me a moment. Individual assignment 2. Okay, that's all the instruction we have. I will also review one more time in the PowerPoint. Let me, I think this is, it's, okay. Can you see my PowerPoint? Okay. Um, so the main section are the section I just reported here. This is for my class, and Dr. Azad, if you like to modify that, please modify it. Let me repeat one more time. You're gonna go directly with the introduction, no literature review, then go with the method, discuss your hypothesis, discuss the data, go to the material and methods, discuss your variable, method, data analysis process, and go with the results. For the result, discuss your finding as a plot, as a density plot, and as a table, and write something about in the data set you use, the kind of test you use, and your findings. Is your finding significant or not? Then go with the discussion, very short discussion, not more than one paragraph, 2 or 3 lines about the limitation, and then go with the conclusion and policy recommendation. The conclusion and policy recommendation has four main sections: introduction, type of data you use, and the method you are using, your main findings, and finally one or two recommendation for as a policy. And finally, you need to conclude your, you need to add the citation you add for this. This is the very short structural instruction for this assignment. Did I answer to your question? Okay, 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 great. Okay, good. Dr. Azid, do you have anything to add to this, or you are okay with these instructions? Okay. Mm-hmm. Okay. 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 Okay, Doctor, so let me repeat that because the last time the system didn't capture what you're saying here. So Dr. Azadi like in her class to add one or two citation to the conclusion and compare your findings with the finding already reported in the peer review articles. So for my class, this is okay if you like to do that, but this is not a requirement. I like to just focus only on the analysis section. It's always good to compare your findings because if you, for example, if there is a research that show the blood pressure in the black population is a higher and your finding in the white population is higher, for sure you need to check your findings. But if you're on the same way, this is fine. I like you to just focus on the analysis in my class, but it's always good to compare your findings with something else. Dr. Azadi likes you to just have at least one citation and compare your results with that. So I think it's very easy. Everything else is the same way. Okay, thank you, Dr. Azadi. And class, if you don't have any other question, I'm gonna go directly to the RStudio. And okay, probably we're gonna have 4 more minutes to for this, and if disconnected, I'm gonna go with the next session. Most of you know that. I just like to explain one more time. Can you see my screen? Correct. This is our studio PowerPoint. I'm going to show you four different sections in our studio. Okay, this is the syntax panel or code panel. This is the data panel. This is the plot panel. Number 4 and number 3 is console panel. Usually you can give more space to any of this panel by click and dragging to the left and right. So this is the basic for for the RStudio. Okay, let me go to an example, and in this okay, here, this is my RStudio. Let me bring here. We have four different data sets, and okay, this message shows that we're gonna be very close to the end of this session. We have four different data sets. We have a Medicare national data by county, we have imaging data sets, and we have Minnesota data, either the admission or hospital reports. First of all, you need to make sure that your data set is in the CVS format. Some of you just run the codes and didn't get any result because you are working with the Excel file. If you try to work with Excel file in the class, this is fine, but make sure to fix the header. You don't, for example, in the usual data set, this is example from the Minnesota hospital admission care, and as you see, this is a first row of data is a title, the second row is a data current, this is another title, and this is the real name of variables. If you try to work with this Excel file, remove the 1 and 2 and started with this one, so RStudio will recognize this row as a name of variable. Otherwise you can see x1, x2, x3, and it's really hard to understand which of them is the real um, file you are looking for. The other point is, before changing the file to the CSV, make sure to remove the separator, because by default Excel uses this divider, comma, as a divider for more than 3-digit numbers, so you need to remove that. For that part you can go with Excel. Let me open an example here and change the format of the table. For example, if this is 100, okay, this is 10,000 here, and if you look at this format, right click, format cell, and usually there is a this there are the Excel by default report like this. So if you convert this to the CSV file, RStudio consider that as a string variables, and the 10,000 RStudio is nothing, is a numbers, is a string variable, is like as a name. For that reason, you need to right click on that, go to the format of cell, change that to the general format without any separator here, something like this, pure number. Or the easiest way, just go in my class, I posted all of the data you need as a CSV file, so you can download those data and just use them. Okay, I'm going now with an example from Medicare National Data by County. In this example, I like to compare the hemoglobin between black and white population. For me, this is for the entire data sets, and I'm using the Medicare National Data CSV.csv. This is the file. First of all, I need to read the file. I'm reading the file, and then I'm looking at the name of variables. Here, this is all the name of variable in the data sets, and because I'm going to compare the hemoglobin between black and white population, I need to find this in the data sets. This is the hemoglobin, this is it. I find, okay, this is here, percentage of hemoglobin white and percentage of hemoglobin black. This is two variable I need. Okay, so when you find this, you can copy from here. I already did that, but I want to show you here, and paste here only the name of variable without any code. If you look at here, there's a code here, started with code. Just go with this. The same for the white population, and with running these codes And always you need to control your data for the missing, because in some data set there is some missing, and if you don't control with it, this comment say this na.remove equal to true, says to RStudio that ignore any missing in the data set. So, and go ahead, if we run this, we can see the mean population. This is 83, 84. The 83 is the mean of percent number of percentage of black population, hemoglobin 83, 84 for the white. I also need to go with the standard deviation. This line, these two lines compare the standard deviation. I have 6.5, 6.2, and then with my table commands I can go ahead and see the number of observation. I have 1343 for the black population, I have 2196 for the white population. And so here till now I have all the information for this table. I have n, I have mean, I have the standard deviation. I also need to go with the p-value. The p-value is here. This line of codes compare the t-test is a comment, data is the name of data set, percentage of hemoglobin black compared to the hemoglobin white. And if I run this one, I can see this result. Usually you can see the means here. Can you see 83, 84? This is the same as here, 83, 84. And here I have different observation here. You already different values here. You already knows about that. This is the t value. This is the degree of freedom, and this is the p-value. This is the part of the findings that you need to report that. As you see, the p-value here is 3.66. A on power of minus 10 is it's a very small number, something like this: 1 2 3 4 5 6 7 8 9 3 6. This is a very small number. Usually if you go with a 4 decimal, it's going to be 0 0 0. It's strongly significant between black and white population. And then if you go with box plot, you see here, I can see this is the mean is almost 83, 84 black white. And these, because we have the means in the same base, so I don't consider them as usual. When you go with a percentage, there is not, there is no outliers with the data set, because the percentage move between 0 and 100. So I don't worry if you are working with the Medicare national data by county and you are working with a percentage, because some of the students are working with the numbers. When you are working with the numbers, you need to just take care of outliers. And then you can just go ahead here and copy this. You can you know how to copy this. You can click on the spot, copy to the clipboard, and click on the copy, and go in the Word document and press Ctrl V together and paste this figure here. Usually in the draft, yes, okay. Usually you need to report. This is two places for changing the variable. This is the code. This is the first variable here. This is the second variable. Let me show you an example. This is the name of dataset, right? You consider you want to compare this, for example, percentage of diabetes, right? This is the percent. Let me go with percent I black. I like to go with percentage. I just need to change this one. I black between black, I exam, and I need to find I examine white. This is I examine white. And so, okay, this is the figure 1 comparing Medicare. This is Medicare enrollees with eye exam. I need to take care of this label between black and white, black, white. I don't need this bracket, and the percentage should be percentage of I exam, right? I exam, and the other percentage is, this is the black, this is a label for this one, this is a black, your first variable is black, your second variable is white, this is here. And if you run this, you can see this plot for black and white with I exam. So I also need to fix this. Okay, I started next session. Okay, class, welcome back. I need to share my screen one more time. Okay, share this one. Okay, are you here? You asked me a question, Mania. Okay, Mania. Okay. Okay, let me go back again to the box plot. You have two variables here. This is the first variable. This is for this variable here. This is for the second variable. You need to change the name of variable. You need to change the title, and you need to change the label here. Y label. This is Y label. So if you run this one, you can see the same plot here. So what's happened here? Okay, this is it. This is the plot. Did I answer your question? Okay, you can try in your what's your topic? Uh-huh. Okay, I have an example for you in the Minnesota data. You can try that with me in your topic to see, because my next example is for the Minnesota data. Okay, but you know, the structure of this syntax is the same as it is, so there's not significantly different. Just the only name of data set, name of variable changed. The next part you need to go is show the density plots, and this entire code from 37 till 45 is for density plot. The density plot shows the how is the shape of your data. As you see, most of the part is um, normal distribution. I can say this is very close to the bell shape. I'm ignoring this section, is not more than 2 or 3 variables. If I go with box plot, you can see this is for only these 4 variables here. And I see this is the type of plot you need to report that. And for your table and for your data, this is the only place you need to change. This is, you can change on these 2 variables. And don't ignore that any type of any name you give it here, that's okay. You don't need to change this name, because if you change this one, you need to change entire these codes. The only important part is this variable, and this title, and this one here, a label for this A and B for this legend. Okay, this is an example for Medicare national data by county. My next example will be with Minnesota health data set. The Minnesota health data set, please mute your computer. First of all, make sure to use the correct data sets and look at the name of variables here. Let me remove this, so I don't like to see anything like this several times. Let me back to here. Make sure to, and this is the data set for the Minnesota data. This is the data I'm using here. This data are useful for a few of you that are using the Medicare Minnesota data for number of admission, for example, cardiac admission, chemical admission, mental. This is any type of data, you can see that. For this example, I'm going to compare total acute care admission and total not acute and nursery care admissions. Um, do you have who asked me a question? Money, Money Mar. Okay, Money Mar. Is it okay? Okay. Uh, are you using this data set or are you using the hospital data sets? Admission data. And your topic is comparing which variables together? Okay, medical surgery and cardiac surgery. I believe it's some places here. Here, this is medical surgery and cardiac surgery, right? This is two variable you are using. So for this, look at this example, and then I will share with Dr. Azad. I think Dr. Azad already shared the master data with you. You just need to change the name of variables here. For example, for total acute care, you can use medical surgery admission, and for non-acute care, you can use cardiac admission. These is two variables you need to change to run your data sets. Um, okay, class. First of all, you need to go with the means. See the means here. This is all the part is the same part. Mean, standard deviation, and number of observation, and the plot. The only difference is, and then you can see the box plot. This is the place I want to explain for you for the sensitivity analysis. Sensitivity analysis is good when you have a long tail or you have a lot of outliers. As you see here, I want to compare the acute and non-acute and see I rarely can see the mean here because there's a lot of big hospital here, or probably very out number of huge number of admission, more than 40,000 compared to less than 2,000. So this is the place for sensitivity analysis. For the sensitivity analysis, I need to eliminate my observation to the bigger for the higher part of the box plot that I can see here. For example, here I can see this acute care with a standard deviation is stay almost in 10,000. So my cut point here is 10,000. I'm generating a new data set, call it Minnesota subset data, and for this subset data I eliminated any observation more than 10,000. So this is the code to subset the data set. This is a new data set and call it Minnesota, and let's see how is the distribution of data in the new data set. Okay, now I can see better. Even maybe if you can go with 5,000, probably give me better shape. Let's see. Okay, 10,000 and 5,000 almost the same, so I stay with 10,000 because I like to keep more observation in the data sets. Okay, this is the new data. I'm testing that. I like to show you why I'm trying to understand. Is it after removing the outlier, is it any significant differences or no? So the first t-test is here. Okay, this is the same t-test. The only difference is the main t-test here is this data, right? This is for this original data set. Here is MNTA, and this is it, MNTA. If I run this variables, the name of variable is this is I have 3.17 e on power of -7, and if I run with this I have 1.3. Let me give you a comparison here. Okay, it's reduced here, it's increased here, but basically this increase did not change significantly. So I can say even after removing the outliers, there is a still significant difference between total acute care admission and total non-acute care admission. So this is the place you can reference to this test and say I run the sensitivity analysis, and after even removing the outliers nothing changed, so I just stay with the original model. And then you can see this is the density plot for entire data sets, and this is the density plot for after removing outlier. You can see the shape is really similar. Look at this. This is, you can see this. Look at the red line. You can see here. Look at the blue line and compare with this. The shape is the same shape, so I can say there is no significant difference between before and after removing outliers. For your specific question about the medical surgical admission and non-cardiac, this is the type of analysis you need to do. That you can just change this here, medical with cardiac. I'm gonna go with this example to see. Okay, this is the this is the means. You can go with the same as a standard deviation, and okay, come on, this is the standard deviation, and then you have my table commands to see the number of observation you need to see. Okay. Okay, you have mean, standard deviation, number of observation, right? You have all of them here. You only need to go with t-test first, and the t-test, you're going to change the cardiac admission with what was that, medical admission, cardiac with medical. You can switch these two variables, so you can, anyhow, it doesn't matter which of them is the first. There is significant difference, and you can go with a box plot and change this cardiac with medical, change this title and say comparing admission cardiac and medical, change this one, and cardiac and medical. Make sure to fix this in your codes. And this is cardiac, this is the place you need to change cardiac and medical. This is it, and that's the box plot. You need to see this. This is what's happening here, because this is a subset data. I need to go with original data for your code because I didn't use the subset for your codes. This is box plot for your example, and then you here you just need to change this to cardiac and medical, and here you have to change this between cardiac and medical, and here this is the other place you need to change that, medical. This is it, and you have all the information to report your findings. This is an example for how to modify your codes to see the to fit that with your example, with your topic. The other type, okay, this is the imaging. I'm gonna go give you one more example here. This is the comparison between MRI and CT using the Minnesota imaging procedure dataset. First of all, you need to read your datasets. This is the data. Okay, and this is name of variable. This is a small dataset. And in this example, I like to compare the procedure, the MRI procedure in hospital with the CT scan procedure in the hospitals. So first of all, I'm generating two datasets. One dataset for MRI, the other dataset for CT. This is MRI and CT. I have two datasets. Then I go with the means. This is the mean for MRI. The dataset is MRI, this dataset, and this is MRI's procedure. and I have the means for CT. This is the CT data set. This is the means. You know that this is the standard deviation and my table for that. And finally, I need to go with the t-test. The t-test compare MRI. This is the data set for MRI. This is the data set for CT. I'm looking at this. The p-value is 2.11 e on power of minus 5. This is highly significant. Then I'm gonna go and compare box plot. This is the box plot for this, and here I try to eliminate it, a few outliers here. You know how to do that, and just I eliminated any observation more than 2000 more than 2000, yes, because this is a small part. Look at this, is almost 5000 here. I stay with this. uh, if I remove that and I look at this box plot, you can see the shape change to this. And then I'm testing a new data set to see, okay, here 5.6 on power of minus 5 in comparison with this. There is no switching in the results of the t-test. So I can say after running the sensitivity analysis, you can stay with your original analysis and report this mean, standard deviation and number of observation 129 for each. And finally, you can look at the density plot to see how is the shape of the data. This is the MRI, this is the CT. They are almost normally distributed. This is three different examples for three different data sets. I have one final example for you, because some of you compare using the medical national data by county but using two different states. The only differences with these codes with other codes is this code is very similar to the Medicare data by count with the previous codes. You just need to generate two data sets for each state. For example, in this example, I'm going to compare the California with Arizona in terms of percentage of ambulatory visits overall. So I have one variable overall ambulatory visits, and I have two states. So here I call my data set with this code Virginia, Maryland. So it should be you can call it any name. So because I changed, I don't like to change that longer. So you can call this any name. You can call it temporary file. You can call it um, the same file. I call it Virginia, Maryland. Okay, it should be Virginia, Arizona, but anyhow, I didn't change that. And then I have two data sets here, one for California, one for Arizona. Then I'm gonna go and compare ambulatory visit between these two states. This is here, this is number of observation, and this is the t-test. The t-test is 0.51. This is not significant differences between these two states. And I like to see the box plots. As I look at the box plot, there's rarely outliers here, so I don't consider these three observations as outlier. This is really normal distribution, you can see that. And if I go with this density plot, I can see very almost normally distributed data. So I can say there is no significant, based on this result. RStudio used a Welch to sample t-test, and based on this, there is no significant differences between number of ambulatory visits in California and in Arizona. So class, it was four different examples for different type of topics that you are already using. So if you have any question for me, I'm here to answer your question. If not, my presentation is finished now. Go ahead, Manya. Mm-hmm. Which exercise? Okay, before asking answering your question, class, do you have any question for the individual assignment too? Okay, Moni, I will answer your question later because I like to finish the individual assignment two questions first. Okay, go ahead. Mhm. Yeah, you don't need to report to RStudio. Yes, yes. Just say one citation for why this is the quantitative, one citation there. The other citation is for wedge sample t-test. I already put that on the class. That's going to be two different citations. Okay, okay, great, thank you. Okay, yes, okay, man. Sure. Hopefully, I answer all the question, but if you have any question, it's okay. Can send an email. Yeah, sure, sure. Okay, any other question? Okay, if not, I'm gonna go with your question, Manuel, to answer the exercise 4, correct? Okay, exercise 4. Class, thank you for being here. If you like to leave the session, this is okay because we are officially finished with the individual assignment. Thank you for being here. I'm going to go and to answer the question about exercise 4. Okay, what's the question? Mm-hmm. Okay, okay. What do you mean? You didn't get the same coefficients? You didn't get any results? Your question is you didn't get. Okay, okay. Let me run. For which model? All the models or only one models? Probably you didn't get the ownership. You didn't get. Okay, this is table 4. This is model 1. You didn't get a result for ownership, correct? But you have owner 1, 2, 3. Okay. It. Yes, sure. I think I need to stop sharing and then you can share. Okay, I stop sharing and you can provide. Let me also switch this so system can. Okay, okay. I see here. You have the same result that I have. 3 ownership 1. You have the same results here. I'm looking at your model 1. This is here in the console. Okay, okay. This is number observation. Mm-hmm. Step 8, yes, yes, you can go. I can see here. Okay. What's the question for step 8 before step 8? This is 0, 1, 2, 3. This is the ownership 0, 1, 2, 3, and the 0 is for non for profit, 1 for profit, 2 for public, and 3 for other. Okay. These values is on these are for hospital ownership, yes. This is a number of observation for hospital ownership. No, that's not for bed categories. For the bed categories, there is other codes called it HOSP. This is here. The codes for the bed category is line 63. That's it. Run this one And you see here 6, 7, and 8, and the exercise asks you to summarize 6, 7, and 8. So the number of observation for 6, 7, and 8 is going to be 315 plus 171 plus 272, because the exercise asks you hospital more than 500 observation, 500 beds. That's the tricky part of this question. You have 1, 2, 3, 4, and for 1, 2, 3, 4, 5, and for more than 500 beds, you need to summarize sum the 6, 7, and 8. Yes. Okay. Okay. For no, I cannot see your Word document. You want to share again? Probably I can see that. Yep. Are you asking about the coefficient for the? Okay, please share your screen. I can see that. Do you want to share again so I can see your Word document here? Maybe you can minimize the RStudio and privacy behind of RStudio. Okay, here. Okay, I see. For these variables, you can go with my table. Go to the line 72 of the RStudio code. 72. Oh, I see. The 72. Okay, here change the moderate hospital to HOSP. That's it. Change that to HOSP. Yes. No, complete. No, don't keep moderate. Remove the moderate also. Just okay. Remove that. HOSP. The same for line 75, 78, 79. Yes, remove that HOSP. Okay, and the same for 78, and the same for 82. Okay, I keep that in the, yes, remove that and type HOSP. And you want to run this to make sure you have observation. Okay, you have this 3000. I know this is week 4, so for that reason I try to leave some mistake to make sure you are fixing that row in the data. I didn't change that. This is for the exercise 3. I didn't that for exercise 3, so for sure that's for the previous codes give you for high competitive markets, but because you already run the high competitive market for the day for the exercise 3, your dataset has already all the information. But for this assignment, the table 4 is only for entire hospital, so you just needed to fix that part of the codes. Yeah. Yes. The means. The means is a very easy part. You can go with the means comment. Mean, open bracket, hospital dollar sign, and the name of variables. You want, okay, copy the line 72 from table, just from table. Copy from table bracket hospital. That's it. No, copy. You are copying from the first line. I'm copy from the table. Only table bracket hospital. Can you see this? Yes, copy from this. Copy that one. Paste to the console. Change the table to mean. Enter and see the means for this. Okay, repeat that and change the mean to a standard deviation. SD, and you now no dot the SD with one word SD. Okay, and you can see the mean. That's it. You can go with the other variables as well as the revenue, discharge, anything else. Okay, for any other variable you like in the data set, you can go with these two comments. You can go with my table command for number of observation. You can go with the mean command for mean. You can go with the standard deviation command for standard deviation. Okay, we're gonna have probably the live session gonna be ended shortly. So go ahead with your questions ended. I'm gonna go with the next session. Okay, go. Mm-hmm. Okay. Okay. I'm not following your question. You are asking about. Mm-hmm. Mm-hmm. This is a scatter plot. Scatter plot. Okay. For finding the relation between Medicare discharge and Medicare ratio, you just need to look at the coefficients. If you look at the coefficient, the Medicare discharge ratio coefficient is minus 551, 5.18 million, and Medicare discharge ratio, Medicaid discharge ratio is 15 minus 15.1 million. This is the okay. It does mean both of them is significant. Yes, you are right, correct. Yes, stay with that. Go to the yes. Let me see this. Yes, yes, this is the correlation. It does mean there is a negative relationship between hospital benefits and Medicare and Medicaid ratio, and both of them is significant. Both of them is negative. So more likely hospital with more Medicare patient and for more Medicaid patient are more likely to have lower benefits. This is the message. So you don't need any box plot to show this. Yeah. Basically, with box plot, you are not able to show the coefficients. No, that's correct. The models back to the regression model. We have two regression model, so the model back to that. The model done back to the plots. See here, this is model 3, line 103. This is the place you can see these two variables in the model, Medicare discharge and Medicare discharge. Yes, this is the only place you can see these two variables in the model. The last two, can you see them, the last two variables? Yeah. Okay, this is the coefficient for them, and as you see there's three asterisk here. It does mean they are highly significant. So yes, yes. Okay. Okay, any other question? Okay, perfect. Class, do you have any other question? If not, I'm not going to start the next section. So thank you very much for being here. So please keep hard work, and thank you. I know this is not an easy class, but I'm here to help you. Hopefully, we're gonna be okay. Okay, you take care, everyone. Thank you. Have a good. You're welcome. Goodbye. Goodbye. Okay, class. This is the end of the live session, and I'm gonna post this shortly in the Okay, Nicholas. Goodbye.